Hi, I'm Paul Bechwith with the University of Ottawa Laboratory for Paleoclimatology. This is part 2 of how to become a climate scientist in 15 minutes. So I have to revise the 15 minutes to 30 minutes. So what I was showing was this is the ocean currents, sea surface temperature anomaly. And this is the date, so this is April 3rd, just a few days ago. What you can see is the Gulf Stream coming very strongly across the Atlantic here, the North Atlantic. And you can see there's cold water coming down from the Arctic. This is through Nares Strait to the west of Greenland coming down. There's also cold water coming down from the Fram Strait. And this water is then coming across the ocean, and so it's like we have two paths of water, the very warm Gulf Stream and then the very cold water from the Arctic, and they're clashing right here, so you're getting a lot of structure here. So if I look at this particular region, the anomaly is minus 10.2 degrees Celsius colder than normal just in that region, whereas right next to it here, it's about plus 8 degrees Celsius almost. So this is a huge temperature difference. So you can see all of this structure here as there's a battle between the meltwater and the cold water from the Arctic clashing with the warm water. So we can go back in time here and see how this pattern developed. And this cold pool is becoming a permanent feature in the last little while. And it's very concerning because it means that the ocean currents in the entire Atlantic are rearranging. And I showed in the previous video how they're shifting in the North Pacific as well. So if I click here, I can cycle back to the previous data. So this is March 29th, and you can follow it as we go back. It's about 5 days each different image. So we're going back in time, and what you can see is how the battle is developing, is proceeding between the cold and the warm water. So the Gulf Stream here, very powerful. The current, they're almost hitting each other at 90 degrees in this tug of war or tussle. I'll go back a bit more. So please Google Earth Nullschool and bring this stuff up. And once you know how to use the interface, you brought this menu up, remember, by clicking Earth. Wherever you click on the map, shows the latitude, longitude, and it's showing the ocean current speed in this case and the direction that it's going, and the temperature anomaly depending on what you set. Bring up Earth to bring the menu again, and we'll go back in time more here and see what happens. Okay, so what you can see is you can see the variation as we go back. So now we're at the beginning of the year, and you can see this very, very warm temperature anomaly from the Gulf Stream, and there's this throughout the whole winter season, there's been this strong water coming out from the Arctic and the cold pool here, and they're battling each other. Let's have a look and see. In a few videos ago, I talked about the destruction of the coral reefs in Australia. So we've got Australia here. Now the coral reefs, the Great Barrier Reef, stretches this enormous distance down the coastline here. So let's zoom into this region and see what's happened with the sea surface temperature anomaly. Okay, get it nice and big, just zoom in. Okay, so maybe that's a bit too big right here. Let's try this. Okay, so this is at the beginning of the year. This is January 14th, and now we'll come back up to the present, in 5-day increments, and you can see the sea surface temperature anomaly. Actually, the water, the blue, is colder than normal, just slightly colder than normal. This is slightly warmer than normal. Not much happening there. There's some warm water down here, 1.1 degrees. So if the water gets too warm or too cold, then the polyps, the symbiotic the symbiotic plankton, the zooplankton that are living on the coral in a symbiotic relation with the polyps, they take off if the water is too hot or too cold, and the coral bleaches. They contain the color. They give the coral the very bright, vibrant colors that we see. So when they leave, the coral turns white. You're just seeing the polyps, and it's damaged. And if the zooplankton will return, if the water temperature returns to normal, and they return within a period of number of weeks, then the coral can revive. So right now the coral is on death watch because there's vast regions of the coral reefs that have bleached. But let's see why it bleached. So I'll go forward in time here, and you can see the change in temperature. So look at this water here. Already, so the water became very warm towards the end of January. We'll keep going. And you can see the warm water coming across. Okay, there's some colder water, warmer water. I'll just cycle through. There we go. So, you know, by mid to the end of February, we had all this yellow, which was, you know, water 2 degrees, 2.5 degrees above normal, coming down vast parts of the reef. And on this side here, and this is starting to really stress the corals. We'll keep going further. So the water stays warm, you know, dropped a little bit, but it stays warm. And then it's picking up again, especially in the northernmost regions. And you can see, you know, you can see what's happening. So this is just, this is in March now. So the water was warm over a sustained period of time. Here it is. So this is again the 2.5 degrees. This is more like, you know, a couple degrees warmer than normal. So the coral is that close to a threshold to be damaged. So and then it's still very warm, but it is so it's warm there in pockets. But you know, hopefully it cools down and it gives the coral reef a chance to recover. That may be happening. It's going to be a toss-up. But probably it's estimated that up to 50% of the coral that was bleached will die. So so you can see, you know, and the coral reefs, it's the largest, one of the largest ecological points on the planet of great importance. I mean, it's basically the rainforest of the ocean, and we're seeing it dying in front of our very eyes because of abrupt climate change. So what else can we see? You can get some chemistry. This is the CO and this is the CO2 at the surface. So you can see in the southern hemisphere, we'll go out a bit here, and you can see how the rates vary with latitude. So down here, we're about the 400 parts per million or so. Which I thought that was the global average, is about 406 or so. You can see areas here, these areas are a bit lower. We generally, as we go up into the higher latitudes, you can see area, you know, this is as we go up over Asia. Of course, there's areas, there's point sources of pollution here from the major cities where the CO, this is carbon monoxide, is much higher. And also the sulfur dioxide is much higher. Continuing with the CO2, I'll come back to sulfur dioxide. You know, if we go up into the Arctic, you can see that the levels there they're not quite as high as over parts of Asia. Now the SO2 is very important because we produce a lot of SO2 from industrial processes, from power plants and so on. So you can see the heavy industry areas that produce a lot of the SO2, you know, hot points, you can zoom in and so on. And the thing about sulfur dioxide is it actually, when it's in the atmosphere, it can reflect sunlight and cause some cooling in that region. So this is one of the things, it causes basically global dimming, and if we were to remove all of the SO2, if we were to shut down industry overnight, we remove the SO2, we would warm, it's debatable how much we would warm. We'd warm half a degree, maybe a degree, just from that alone. So we're phasing out power plants that are coal-based, and also we need to do this for oil. We need to go to a renewable energy supply, but we're going to get some warming because we're removing the SO2 blanket. We're actually cleaning up the air, and there's going to be warming resulting from that we cannot avoid, but we have no choice. We have to do this. Let's have a look. There's also information on particulates here, so you can see what's happening. So this is this is the dust extinction. So it's units on how much, when you've got a lot of dust in the air, it will block light, and the amount of blockage increases as we go across here. So